Okay, we're going to talk about conjugates. Now, you've kind of done this before. When we don't want a middle term, we can do this. If we have x minus 5, and then we multiply that by x plus 5, we eliminate the middle term, because then we have x squared minus 5x plus 5x plus or minus 25. That eliminates our middle term. Okay, so conjugates have the same first term and second term, opposite sides in between. Okay, so for example, if I had x minus root 3, the conjugate of that would be x plus root 3. Okay, and the reason we're going to be using conjugates is to get square roots out of the denominator when they're added to something else. If it's a plain old square root in the denominator, we just need to rationalize by multiplying by the same square root. But if we have something added or subtracted to the square root in the denominator, now it becomes much more difficult. And this is what we're going to do. We're going to rationalize the denominator using a conjugate. This is the way when we have a number added to a radical or two radicals added together in a denominator, this is the only way to create a jailbreak that's going to work. Okay, so here's what I mean by that. In the first one, in the numerator, we have 1 plus the root of 3. And in the denominator, we have 5 minus root 3. Now, the 1 plus root 3 in the numerator is perfectly fine. We can leave that forever, okay? All day long, that can stay there. However, that root 3 in the bottom is a problem. We cannot keep that. But we can't just multiply by root 3, because watch what happens. Don't write this down. Let's say I multiply by root 3, top and bottom, like you're thinking, oh, we're good. But look what happens. You get 5 root 3 minus the square root of 3 times 3, so that's 5 root 3 minus 3. We didn't get rid of it. We just moved it. So that doesn't work. So when we have something added to the root, we have to use the conjugate. Remember, the conjugate is the same two numbers, and between the two is the opposite sign. So originally it was a subtraction, now it's a plus. Now remember, on the top we have to match it perfectly. 5 plus root 3. The numerator and denominator should be exactly the same. That way we're actually just multiplying by 1. And multiplying by 1 doesn't change our value. Okay, we're just manipulating. So in the numerator here, we're going to have to FOIL. 1 times 5 is 5. 1 times root 3 is root 3. Root 3 times 5 is 5 root 3. And root 3 times root 3, be careful of this, is root 3, and there's two 3's there, okay? Because there's a root 3 times root 3, and so we can put that under the same radical. We'll simplify the numerator in a minute. We're gonna do the same thing with the denominator. 5 times 5 is 25. 5 times positive root 3 is positive 5 root 3. 5 times negative root 3 is negative 5 root 3. And then we're going to have a negative times a negative is a negative. I mean, negative times positive is negative. And then we have two 3's. Okay? Now let's start simplifying. Now some of you are going to see the pattern and you're not going to have to write out as much, and some of you are going to have to. So what do we have in the numerator here? Well, we could put these two together. Okay? They have the same index, which is 2. They say same radical, which is 3. Well, this is 1 root 3 and 5 root 3, so that's 6 root 3. Now look at this one here. This one can jailbreak. So what's the square root of 3 times 3? Well, that's really just 3. And then we still had our 5 over here. So 5 plus 3 is 8. Okay, that's our numerator. Look what happens to our denominator. The middles cancel out. That's the whole point of using the conjugate. 5 root 3 minus 5 root 3 goes away. The 25 is sitting there waiting. And then look, what's the square root of 3 times 3? Well, the square root of 3 times 3 is just 3. So we got rid of our square root in the denominator, and so this is 23. And so that is my answer. Now, the only way that could be simplified more, if it was 6, 8, and then a 24, and you could divide everything by 2. But because of that 23, there's nothing that is divisible in all of these. So that's my answer. Okay, so you can see that's a little complicated. Let's do number 2. Negative 2 minus root 5 all over 1 plus root 5. As soon as you see that it's a 1 plus and a root, conjugate time. And you've got to really think through what's the conjugate. The conjugate is the same numbers and then the opposite side in the middle. And then the numerator has to match exactly the denominator that we just brought in. Okay? Now we FOIL. And be careful with the FOILing. This is a lot of work. Negative 2 times 1 is negative 2. Negative 2 times a negative 5 is a positive 2 root 5. So we still have negatives and positives to be concerned about here, so you got to be careful. Then we have a negative 1 root 5, or just a negative root 5, or you can put the 1 in front of it. And then we have a negative times a negative, which is positive, and that's root 5 times root 5. In the denominator, we have a 1 times 1. A 1 times negative 5, so that's, or negative root 5. Then we have a root 5 times 1, so that's a positive root 5. And then we have a positive root 5 times a negative root 5, and so that gives us 2 5s here. So let's start simplifying. This doesn't always work this nicely in the numerator, but sometimes it does. In the numerator here, we have a 2 root 5 minus a 1 root 5. Well, that's going to give me root 5, or 1 root 5, because 2 minus 1 is 1. They have the same radicand and the same index. And then this 1 on the end here, a jailbreak can occur, so that's a 5. We still have this negative 2, so negative 2 plus 5 is 3. There's our numerator. And again, you can have a radical all day long in the numerator. Nobody cares about that. I don't know why, that's just the way they came up with it. The middle terms, if you did it right, should cancel out. Negative root 5 plus root 5, gone. And then the last term should simplify and not be a radical anymore. Okay? And so that's negative 4. And that's your answer. It's not pretty. It's just a lot of algebra manipulation going on here. Let's do one more. That's going to be x minus 1 all over root x minus 1. Same thing. As soon as you see you have a square root plus anything, it could be a square root plus another square root, you have to multiply by the radicand. I'm sorry, the conjugate. And the conjugate is the two terms are exactly the same with the opposite sign in between. So I put a plus instead of a minus. And whatever I do the denominator has to be exactly the same in the numerator. Now we FOIL. X times square root of x, that's ugly, is x root x. X times 1 is just an x. Negative 1 in x is negative 1 root x. And negative 1 times 1 is negative 1. Nothing is going to simplify in that numerator, and I'll tell you why in a minute. In the denominator, square root of x times the square root of x is really x times x. Square root of x times positive 1 is positive square root of x. Negative 1 times the square root of x is negative square root of x. And then negative 1 times 1 is negative 1. In the numerator, it looks at first like I can put the square root of x and the square root of x together, which is true. But remember, x and 1, the thing out in front of them, they can't be put together. So this is done. The numerator is done. It's just x root x, it's really ugly, plus x minus root x minus 1. All over, okay, well, if you did this right, your center terms should cancel out. Square root of x minus x goes away. And then the other term should simplify so we no longer have a square root. So this is going to come out as an x and a minus 1. Because we have pluses and minuses, there's nothing we can cancel out. We can't just cross out x's because there's plus and minuses going on there. Okay, so what I want you to do is try this, try the homework, and then we'll spend some time doing homework problems together to make sure you understand this.